So reactions of monosaccharides. One of the reactions that monosaccharides undergo is oxidation. And we have talked about these types of reactions in the organic chemistry section. We talked about the relationships between alcohols and aldehydes and carboxylic acids. And so this plays right into that. The monosaccharides can be oxidized in different ways, and they can produce three different types of acidic sugars. So if you have a weak oxidizing agent, and examples of weak oxidizing agents are Tollens and Benedict's reagents, and we used those when we did the aldehydes and ketones. That will oxidize the aldehyde end of aldoses and form aldonic acids. So here's glucose with a weak oxidizing agent. The aldehyde function group here will get oxidized, and aldehydes form carboxylic acids, right? So this forms a carboxylic acid functional group up there. In terms of naming, just not because I don't believe I'm going to test you on this, but just so that you know why the names are here. An aldonic acid, you take the glucose name and you change the ending to onic. So this is gluconic acid. So sugars that give a positive test with Tollens and or Benedict solutions are called reducing sugars. Because when this sugar encounters an oxidizing agent, it becomes oxidized, but it is the reducing agent. It's a little bit confusing. When something is oxidized, it's acting as the reducing agent. When something is reduced, it's acting as the oxidizing agent, because an agent does something to someone else, right? A music agent or an agent for an actor, they don't actually go star in the movie, right? They arrange things for their client. An oxidizing agent oxidizes something else. It is not oxidized, it is reduced. So you got to get those kind of straight in your head. So a reducing sugar is oxidized because it's the reducing agent. And so these will give positive tests with Tollens and Benedict's solutions, and we're going to do that in class today. All the monosaccharides are actually reducing sugars. Aldoses we understand because the aldehyde functional group is oxidized to a carboxylic acid. But do ketones get oxidized by weak oxidizing agents? No, they don't. So what's going on that ketoses also act as reducing sugars? What happens is that the conditions with Tollens and Benedict's solutions are basic conditions. And under those basic conditions, ketoses will actually do a rearrangement of their structure and become aldoses. And I understand that that's weird, and we don't want to go into the details of that. But the bottom line is that all monosaccharides are reducing sugars. All of the monosaccharides, whether they're aldoses or ketoses, they're all reducing sugars. The two other types of acids that can be formed, one is formed if you have a strong oxidizing agent. With a strong oxidizing agent, you end up oxidizing the aldehyde end, but also this primary alcohol end. This is a primary alcohol. The alcohol is just this carbon is only attached to one other carbon, so this is a primary alcohol. So you end up with a dicarboxylic acid. It oxidizes both ends. These are called aldaric acids, and so glucose becomes glucaric acid. So that's another type of oxidation that can occur. And then enzymes, it's hard to do this without enzymes, but enzymes can oxidize only the alcohol end and leave the aldehyde end alone. We can't do that very easily with strong or weak oxidizing agents because the aldehyde end oxidizes first, but enzymes are amazing and they can do that. And so these are called aldaric acids, and so glucose becomes glucuronic acid. So these acids are oxidized sugars, and their name is dependent on which end is oxidized, one or the other or both. Another thing that can happen is reduction. that carbonyl group can be reduced to a hydroxyl group. So remember, alcohols could be oxidized to aldehydes, and aldehydes can be reduced back to alcohols. So if we have glucose here and we reduce this, then we get an alcohol. Well, it's a polyhydroxy alcohol. It's got alcohol groups all over the place. And this is called a sugar alcohol. So this would be glucitol, and it's related to glucose. Its other name is D-sorbitol. Have you heard of sorbitol? Or mannitol, perhaps? These sugar alcohols have a sweet taste, but they don't contribute to tooth decay, and they are much lower in calories. And so they're used as artificial sweeteners, especially in gum and some candies. And they don't contribute to tooth decay because the bacteria can't use them as food, so that's great. But if you eat too much of them, you can give yourself some serious intestinal distress. Okay? It's not going to kill you or anything, but you might be uncomfortable and you'll have to stay pretty close to a bathroom for a few hours. So just, don't eat a whole package of sugar-free Twizzlers. It's not a good idea. Sugar-free gummy bears, no. A couple is okay, but not the whole package. Another thing that can happen is glycoside formation. So the cyclic forms of monosaccharides are hemiacetals, right? Here we've got this carbon, it's got a hydroxyl group here, and this ether linkage over here. A hemiacetal can react with an alcohol to form an acetal. Now this carbon has two ether linkages. This is the full-blown acetal. And when we do this with monosaccharides, they're called glucosides. So glycoside. That is glucoside. A glycoside is an acetal formed from a cyclic monosaccharide by replacement of the hemiacetal carbon hydroxyl group with an OR group. And these also have alpha and beta forms, because we can have this group being up or down. So this is the alpha form, and that's the beta form. And when they're named, we just name we put a prefix on the beginning relating to the alcohol that this came from. So that's methyl. So this is methyl alpha D glucoside, and that's methyl beta D glucoside because this is sticking up. And we're going to stop there.